3.4 is over, ooh, words are hard. Graphing quadratics, okay? Flashback, have we graphed quadratics before? Yeah, we have. What did they look like? What shape? U. These look like the letter U, whether it was perfect like that or upside down, okay? So we have done this before. What's your question?
Are we gonna have graphs today?
Yep, today's graphing quadratics, okay? But we've already learned half of it, okay? We already know how to graph quadratics that are in what we call vertex form. What we don't know is how to graph them in standard form, but they're going to be very similar, and we're going to learn both ways today. So first off, standard form equation, we've seen this before. Y equals a x squared plus bx plus c. Okay, just a typical trinomial. What the A is going to tell us on these, it is going to be what direction our U is going to be. Okay, so for instance, if A is positive, it's going to open upwards. So it's going to look like this. If A is negative, then it's going to open down. It's going to be an upside down U. Wasn't that the same thing with vertex form that we already learned? If A was negative, wasn't it always going to be an upside down U? And if it was positive, it was going to be regular? Yep, so that's not new. Okay? The next thing, so using A and B, we're going to find out what is called our line of symmetry. Line of symmetry. And the equation that you're going to use for this is x equals negative b over 2a. Negative b over 2a. Negative b over 2a. Engrave that in your brain. Okay?
I got a question.
What's your question?
Is this the last unit?
The last section? Nope, we got one more section after this, but it's short. So that'll be next week. Okay?
When do we take our test?
The following week.
Okay. No, I meant like, is this the last one, last like unit or before final?
No, we'll have one more. Yep. Okay. So, line of symmetry here. Would you agree with me that when we have a U shape, it's always symmetrical, whether it's up or down? So it makes sense that we're going to have a line of symmetry on these. Okay? C is always going to tell us what our y-intercept is. We'll talk about that here in a minute. Okay? If I make a point right here on this U, anybody remember what that point's called? Starts with a V. Vertex, okay? The vertex was always the center of your U. So whether it was the center at the bottom of the U or at the top if it was upside down. Wouldn't you agree? So do we see how the line of symmetry, it always goes through that vertex. Always, always, always. So that's going to be important today. So we're going to do an example. First example, what's the A value on this? Nope. 1, because it's just that coefficient. What's the B value? And the C value. Okay, we're going to be all good on how to find those. A, B, and C. Just the coefficient that's in front of each term. Okay? Is this going to open up or down? Up. Why? Yep, what's positive? Yep, the A value. This 1 right here. That was a weird arrow. That's positive, so it's opening up. Cross off this, okay? It's a little trick that doesn't work every time. It only really works if A is 1, so we're not going to worry about it. Then we have our line of symmetry, okay? Our line of symmetry, we said, always, always, always is x equals negative b over 2a. So what's b? Yep, it'd be a negative 2, which is a positive 2, over 2 times 1, because that's A. So like Claire said, Positive 2 over 2 times 1, which is 2. What's this equal? 1. So x equals 1 is going to be my line of symmetry. X equals 1 would be my line of symmetry on this equation. Okay? Is everybody good on that so far? Okay, let's keep going. So now we want to find our vertex point on this. Okay? So using that same equation, I'm just going to write it at the top of here just so I don't have to keep on flipping pages. So y equals x squared minus 2x minus 3. Okay? And we said our line of symmetry was what? X equals 1. Okay? So now we've got to find the vertex. Well, like I said, if I know that the line of symmetry through my u is going to be at x equals 1, so that vertical line of x equals 1, what is the x value of my vertex always going to be? 1. Because isn't it always going to go through that line of symmetry we said? So if my line of symmetry is x equals 1, the x value of my vertex should also be 1. Okay? I don't know the y value though, but if I want to know what y equals when x equals 1, what should I do? Plug it in. Just plug in 1 everywhere where there's an x. And my calculator will do that for me. So y is going to equal 1 squared minus 2 times 1 minus 3. And what will that give me? Negative 4. Does everybody agree?
Yeah.
Okay. Cool. So I now have my vertex point. And now I just need y-intercept and x-intercept. Well, the trick on these that are in standard form, we actually wrote it on that first page. My c value is always going to be what? What does it say? Flip back. What does c always equal? The y-intercept, okay? This is always going to be the y-intercept. So if I had to write that as a coordinate, what would it be? Y-intercept. Yep, 0, negative 3. Because again, a y-intercept is when x equals 0, what does y equal? Okay? So then we need to find our x-intercept. How do you think we'd find that? So if this is when x is 0, this is going to be when y is 0. So we're going to set y equal to 0 and solve for x. That looks familiar, doesn't it? Isn't that what we did last class? Yeah? Yeah. It is. How do I factor that? What's going at the top? Bottom? Two things that multiply to negative 3 that will add to negative 2. Okay, so 1 and 3 are going to be the numbers, and which one's going to be negative? Yep, the 3. Good. So now we just factor by grouping. So we got x squared plus x minus 3x minus 3. Group together what we can. These first terms are going to have an x in common. These next terms are going to have a negative 3. So when I'm done, I'm running out of room over here. I'm going to end up with 0 equals x minus 3, x plus 1. And how do I find out what x equals?
You said it equals each in terms of
Perfect. And just solve them. So x is going to equal
3
and
and
so that's going to be 2 coordinate points. The first one's going to be 3, 0, and the next one's going to be negative 1, 0. Okay. Sometimes You're just going to know the x-intercept because it's going to be in your table or just like one of the points that you already know, okay, that you don't have to solve for. But if you don't, just like with radicals, okay, we've got to plug in those zeros to figure out what those are, okay? But if it's in vertex form, you should never have to solve for this one. But if you do, you'll still get the same answer. You just got to plug in that 0 for x, okay? Questions on that? All right, so using this exact same equation, we just did all the hard stuff, okay? So now we just got to throw it on this graph and do a couple more things. Axis of symmetry we said was what? X equals 1. So line of symmetry, axis of symmetry, it just means the same thing. So what I can do is I can go to this graph and I can go to where x is 1 and I can just draw like a dashed line just so I can see where that symmetry is. And that's going to help me know that my u needs to be symmetrical over that line. So if I get something that looks kind of funky, I probably did something wrong, okay? Vertex, what did I say that was? 1, -4. Okay, so I'm going to go ahead and plot that point as well. And I know it's always going to be on that line of symmetry. Since I've already solved for my x and y intercepts, I'm going to go ahead and plot those points because I know that those are also going to be on this u. So my y-intercept I said was 0, -3, which is going to be right here. And then I had 2 x-intercepts this time. You won't always have 2. Sometimes it'll only cross it once. Sometimes it won't cross it at all. But this time we have 2. So 3, 0, and -1, 0. Everybody with me so far? Okay, now I'm going to zoom in on this. To have a quadratic, do you remember last time how many points we had to have? We used to like do an XY table, okay? So we'd do this. And we'd put that vertex in the middle. So 1, -4. I'd do 2 points to the left, 2 points to the right, and then I'd go plug those in. You with me?
Yeah.
Remember? Okay. How many points was that total? 5. How many points do I currently have?
4.
I only have 4. What would be a really easy point that I could just put on there without having to do any math? 3, -3, close. 2, -3. Do we see how this is a line of symmetry? Okay? And I know we briefly talked about this in our last graphing quadratics thing. But these points are always going to be symmetrical over this line. So if I knew, for instance, and I don't know that this point's on this line, but let's say that this point right here, -4, 4, was on that line. Well, couldn't I just go over here and count that same amount of blocks away from here and put a point?
Yeah.
Because that's symmetrical over my line. Yeah, those points don't go there, so don't draw those. But that's how this works, okay? So if you have a few points and you don't want to have to do more math, use them, okay? And there's my U. Poorly drawn, but there it is. Okay, questions on that? All right, so this table, this thing still works. You're welcome to do that if that's easier for you. But sometimes it's easier just to plot the points that you know and go from there. Domain and range. We should be good on this. Domain on quadratics is always left to right, so yep. Remember that was always the case for quadratics. The range is my y-axis. This is going to start at -4 and go to infinity. Cool. All right, I'm going to jump down. I want to do intervals before we get into limits. Okay, we'll kind of save the best for last there. But let's say that we have Carter. Everybody say hi, Carter. Hey, Carter. Okay, so Carter's running. Is he going up or down? Down. Okay, that he starts off going down. So his pathway from -infinity to where this vertex is on my x-axis, which is at 1 with the closed bracket, he's decreasing. Would you agree?
Yeah.
Yeah. Okay, Carter's going to keep on running. Now what's he doing? Going up. So he's increasing from where?
One.
1, because it's, again, x is our pathway, right? Remember, our intervals are just our pathways on our x-axis. So 1 to infinity. You with me?
Yeah.
Okay. Questions on that? So, remember with radicals, we are always either going all up or all down, right? We just had one interval or the other. We are either increasing or decreasing. With quadratics, you're going to do both. Okay? You just have to look at where. Last part, limits. So this is a little bit different, okay, than radicals as well. One thing that is the same. Copy your domain down as your approaches. Okay, so that's still the same. And since domain on quadratics is always negative infinity to infinity, these are never changing for these. So negative infinity to infinity, keep it the same. So this is still going to be my left bound, and this is still going to be my right bound. And I'm still going to be finding where y is going. Y is going to be equal to or approaching a number. Okay? So here's the thing. These still work the same way, but I'm going to show you a trick after I explain it. Okay? So stay with me. So the left limit is still the bird thing. So the bird's flying in from the left. As x is going to negative infinity, what's y doing? Just going up, right? Forever. To what? Infinity. Okay? Now my bird's going to fly into the right. As x is approaching infinity, what's y doing? Also going to infinity. Okay? Those are always going to match. If your u is going up, you're always going to infinity, left and right, okay? If your u is going down, where do you think you're going? Negative infinity, for both, okay? So from the left and the right, y is going to negative infinity if your u is pointing down. Questions on that?
So
They're both going to match, but it's just going to depend on if your u is right side up or upside down. So if it's right side up, it's positive, upside down, negative. Questions on that? I know this is a lot. Similar to what we've done, okay? But a couple more added things. So, no questions? All right, we're going to keep going. We're going to do another one. Okay. I want you to use that formula, which is x equals, for line of symmetry, x equals negative b over 2a, okay? So I want you to find the axis of symmetry, find the vertex, and then stop. Okay, so we've got our formula. What is b in this equation? Negative 2. So we've got a negative 2 over 2 times what? Negative 1/3. Okay, so let's go ahead and just simplify what we know. What's a negative 2? Positive 2. And what is 2 times negative 1/3? Two over 3, but negative 2 over 3? Okay. So now type this into your calculator. 2 divided by negative 2/3. 2 divided by negative 2/3. And tell me what you get. Negative 3. Anybody get that the first time? Close?
Yeah, I did get that.
You did get that? Okay. Got to make sure we do order of operations correctly, or we're going to get a funky decimal, okay? So x equals -3 is going to be my line of symmetry or my axis of symmetry. And I can go ahead and plot that dashed line just so I know, hey, this is the line my quadratic's going to go through. Okay? Vertex. I don't know the whole vertex, but I know part of it. And what part do I know? The -3, and that's going to be the x. So I know it's going to be on that line. How do I find the y?
But you plug it in for the, y equals x squared minus 2x minus 3.
So I need to plug in that -3 for x. Good, to figure out what y is. So when I do that, y equals -1/3 times -3 squared minus 2 times -3 minus 3. And my calculator will do that whole thing, okay? So type that in and see what you get for y. What you got? 0. Anybody not get that? Any questions on that? Blake, you got it?
Yeah.
Okay. So now what do I do with that vertex? Plot it. Yeah, go ahead and plot it. You need to know where that is. It's always how you start these. Okay. I don't have a quadratic yet, right? I've just got a line and a dot. So I've got some more work to do. I can go ahead and find my x and y intercepts. You know, I could go ahead and make a table because I know what my middle point is, which is what? My vertex, right? So I could go ahead and make that table if that's where you want to take this problem, or you could go ahead and find your x and y intercepts, okay? Totally up to you which one you want to do. Let's just find the intercepts and see what happens, okay? So an x-intercept is when y equals 0, right? You with me? When y equals 0. Do I have that point yet?
Yeah.
So is it okay that my vertex is the same thing as my x-intercept? Sometimes you'll get lucky and that'll happen. Okay, if you didn't see that though, you'd just plug in 0 for y, and you'd solve it, and you'd still get that, okay? But to find my y-intercept, I need to plug in 0 for x, okay? So when I do that, y equals -1/3 times 0 squared minus 2 times 0 minus 3. What's that going to be? Also -3. So this is going to be 0, -3, okay? Which is going to be right there. Questions so far? Okay.
Wait, never mind.
Yeah, do you have a question?
No, because I was gonna see, because it's like -1/3, so would it be going down?
Yep, it is going to go down. It's going to be an upside down U. Good point. Yep, you can always look at that A value and tell if it's going to go up or down just by seeing if it's positive or negative. Okay? So if I have that 1 point, or I have 2 points right now. I have the vertex and then I have one other point. Can I find another point without doing any math at all?
Yeah.
Yeah, where would it be? -6. Good. Okay. And here's the thing. So I've got 3 points now. And technically, if I would have drawn this table, these would have been 3 of the points of the 5 points in that table. So you're totally welcome to keep doing the table thing if that helps you. Okay? But I need 5 points on this, right? So what I'm going to do is I'm just going to pick any of these x values. It does not matter which one. Plug it in for x and see what y equals, just to get one more point. And then I'm going to reflect that point so I don't have to do any more math, okay? You can totally do that. So when I go up here, I'm just going to use -1. That seems easiest. So I'm going to type in y equals, well, I can't type that part in, but -1/3 times -1 squared minus 2 times -1 minus 3. And tell me what you get. -1/3. Yeah, it's going to be kind of weird. -1 1/3. Okay. So when I go to -1 and then I go down 1 1/3, is that what everybody else got? Okay, cool. So go down. So that looks like it's going to be on this side of my U. How can I find that 5th point then? Just to reflect it. So I can reflect it to the other side. And then I'm done. So as long as you got 5 points, you're good to go. And again, I totally could have done this table, done 2 points to the left, so -4, -5, -2, and -1, plugged all of those in, and I would have still got points. Okay? So I don't care which method you use, I just want to show you one more method that we didn't learn last time. Domain is always going to be what? -infinity to +infinity. The range on this one, so bottom to top, good, -infinity to 0. Limits, what are my approaches going to be? Yep, always going to be the same as the domain. -infinity and infinity, and then my limit. So is this going up or down forever?
Down.
So that's pretty easy. And now we just have our increasing and decreasing intervals. Okay. So here is Aaliyah. Everybody say hi, Aaliyah. Okay, she's running. What's that going to be? So it's our pathway, remember? So on our x-axis, -infinity to, what's this point on the x? -3. Is that going to be increasing or decreasing? Increasing, because she's going up. Good. So -infinity to -3. Okay, Aaliyah's now running the rest of it. And what's that going to be? Up to +infinity. Because it's your pathway, your x, remember? We already know what y is doing. It's decreasing. Okay. Questions on that? Okay. Lots of info, right? For a Friday. I'm sorry. It's going to be okay, though. We're going to practice it. We're going to be fine. Questions, though, before we move on? Okay. So now we have what's called vertex form. Guess what? We've already graphed these. This was in that same unit that we did absolute values, remember? What does K tell me? If I'm going up or down. What about H? Left or right? Up or down, left or right. Okay? So these ones are pretty darn easy. I want you to go ahead and graph this one. Tell me H, tell me K, tell me that vertex, which is just H and K. The line of symmetry. Use a table and graph it. Okay, what's H?
3.
Oh. H.
Oh, wait.
H is 2. What's K?
3.
Vertex is
No.
2, 3.
Oh.
My line of symmetry then, so let's go ahead and plot that point, 2, 3. If I know that that's either the top or the bottom of my U, I know my line of symmetry is going through that point, don't I? What is that line?
2.
X equals 2. Okay, now I make my table, which you're totally okay to do on all of these because it always works, and if it's easy for you, do it. My middle point is 2, 3. 2 points to the left of 2 are 1 and 0. To the right are 3 and 4. Now I take that calculator and I go plug those numbers in. So the first one, y equals negative 1/2, 0 minus 2 squared plus 3. What do you get? 1. Now go plug in 1. What do you get? 2.5. Okay, when you plug in 3, you should also get 2.5. When you plug in 4, you should also get 1, because we know this is symmetrical. 0, 1 is going to be right here. 1, 2.5. Be right about here, and then we just reflect. And there's my U. Is it opening up or down? Was A positive or negative? Negative, so it makes sense it's going down. So that should be something that is a flashback. Is it flashing back to us?
Yeah.
We feeling okay? Okay. Anybody need more time with this? Okay. Second one. I want you to just do the review stuff. So I want you to graph it. Okay? By now you should be able to tell me the vertex and the axis of symmetry pretty easy, and use a table to graph that. Okay? So that's your job. I'm gonna give you about a minute or so to do that. Maybe 2. Okay, vertex is gonna be what?
Negative 3, 1.
Good, negative 3, 1, because H always flips its sign, okay? K stays the same. So if I know that negative 3, 1 is my vertex, what's that line of symmetry gonna be?
Negative 3.
Yep, when X is negative 3. So I can go ahead, make my little dashed line through there. And I know that, sorry, that yellow's kind of hard to see. I know that my graph is going to be symmetrical over that line. I need more points though. What should I do? Chart. And my middle point I already have, which is?
Negative 3 and 1.
Okay, so 2 points to the left of negative 3.
Negative 4, negative 5.
Yep, negative 4 and negative 5. And 2 points to the right.
Negative 2, negative 1.
Okay, so now we go plug those in. We use our calculator to do so. And when we plug in negative 5, what do we get?
9.
Okay, negative 5, 9 is going to be right here. Next point.
3.
Negative 4, 3. Do these two reflect?
Yep.
3 and 9, so negative 2, 3, and negative 1, 9. And now we just make our U. So it should look like that. Raise your hand if you've got that one. Sweet, okay. Good to go on that. Domain, good. Range,
1.
perfect. So bottom to top is 1 to infinity. My limits, I need to rewrite my
Domain.
as my approaches, good. And then where's y going?
Infinity.
Y infinity.
Because the A is not negative, positive.
Yep, A is positive. So that's our little trick on this one, but approaching from the left, we're going up forever, and approaching from the right, we're going up forever. So we're good to go on that. Increasing and decreasing interval. Which one comes first? The decreasing, right? Because we're going down first. And what's that interval going to be? Okay, so we never, one thing really quick I want to make note of, and this goes for, a lot of people make this mistake on quizzes and tests. When you have like a coordinate, so like something going to something, whether it's the domain or the range, okay, so starting from the beginning and going to the end, you are never going to end at negative infinity, okay? The reason for that is that we're either always going from left to right, or we're always going from bottom to top. Well, the only thing that's ever going to be negative infinity is the left or the bottom, right? So that's never going to be the value on the right side. Does that make sense? So you should never have a negative infinity on the right. Okay? Does that make sense?
Yeah.
Cool. So don't do that. All right. So my decreasing interval, so starting from the left, going to the right, we're going from negative infinity, and then what's the x value at this vertex? -3. Because again, that's my pathway. Then the increasing interval, so I'm starting, picking back up from that point and going to positive infinity. And just like negative infinity should never be the right-hand value, should positive infinity ever be my left-hand value? What do we think? For domain or range or in an interval? Would I ever start at positive infinity? Nope. Never. Okay. Now we have x and y intercepts. Do I have any that I know of in my table? Looking at this graph, let's just start with the x-intercept. That's what it asked for first. Is that ever going to cross my x-axis?
No.
No, so if you tried that one, if you tried to plug in 0 for y and solve, you're just going to get something imaginary or like a domain error, okay? Because there's not going to be an x-intercept. What about a y-intercept, though?
I got
0, 19? I would agree. And how did you get that?
I put 0 for x.
Good, 0 in for x. So when you do that, you should get 19. Your calculator will do that for you. Okay? Questions on that? Yes. For range? Okay, so that is your y. So from the bottom to the top, where are you going? So from the bottom, I see that my graph doesn't start until 1 on my y-axis. And it's going up forever. You see that?
Yeah,
Okay. So just the y-axis is all I care about for range. Just like domain, all I care about is the x-axis. I don't care about the y. Okay? Questions on that? Any other questions? We good? Okay. Do you want to do another one, or do you want to keep moving along? Move along? Do we feel pretty confident on this? We're going to do practice after this, so are we okay to skip this one?
Yeah.
Liz, you good?
Yep.
Okay. All right. Converting between the different forms, okay? We're going to start off by converting from standard form to vertex form. A little bit of a rewind to Algebra 1. Going back there again, okay? Anybody remember what we called completing the square? No. Okay. That's what we're going to be doing today. It's really not difficult, okay? Okay. So for right now, we'll go ahead and we'll fill these in, but my method is going to be a little shorter than this. So rewrite the equation so that all of the constants are on one side. It doesn't necessarily have to be the right side. It just needs to be on one side. And set equal to 0. Make sure that your a value is 1. It says if you don't have an a value of 1, this is a typo. If you don't have an a value of 1 to pull out a GCF, I'm going to go ahead and tell you that on the test, it's only going to be 1 for your a value. So we're not going to worry about that GCF thing for right now. Okay? The next thing we've got to do is locate the b value. Divide that by 2. You're going to square that value that you found and then add it to both sides. Then you should be able to factor the left side and then solve like a normal equation. That seems like a lot. Don't you agree? Okay, we're going to sum it up. And here's what we're going to do. So first off, I already told you that the a value is always going to be positive. I want you to just make this whole equation positive. We're going to change it because I don't like the first one that I had. So make this whole thing positive. And here's what I want you to do. I want you to take the equation, don't change anything about it, set it equal to 0. So that's the very first step. Just going to set this equal to 0. Okay. The next thing I'm going to do is I'm going to move that constant to the other side. So I want the constant on one side and the variables on the other. So what's the constant in this? And how would I move that over? Just subtract it. So that's what I'm going to do. So I end up with this. X squared plus 8x equals negative 13. Everybody with me so far? Okay. Now what I'm going to do. On this left side, I want that to factor. Okay, and I want it to factor really nicely. So what I'm going to do is I'm just going to change this. I'm going to take my x, that's going to be my first term, okay? My b value, or this term right here, divide that by 2. So a positive 8 divided by 2 is what? 4. Write that right there. Everybody with me so far? Okay, now don't write this part. I just want you to watch, okay? So what I'm doing here is I'm changing this into this, okay? So what I need to do is I've got to add an extra number. And to find that number, and again, don't write this, if I factored this whole thing out, x times x would be x squared. I would then have plus 4x and plus 4x, which would be a plus 8x. Doesn't that match? Yeah. Okay. And then my very last term, which is 4. 4 times 4 would be what? 16. Do I have that up here? No, I don't. But I just made it into this. Do we all see that? And this one does have a 16. So all I've got to do is, since I added 16 on the left, technically, I just need to add it on the right. So all I'm going to do is I'm going to take this, divide this 8 by 2, and make it this. And then that 4, all I have to do is do 4 times 4. Figure out what that number is, add it to the other side. Okay? Does everybody see why that works? Yep. Okay. And now we just simplify it. So what is negative 13 plus 16? On the right side. Just 3. Okay? And the only thing left to do, if we go back to when we started graphing these, the very first problem that we did today, it was in vertex form, which is what this is. But everything has to be on one side, so I just need to subtract that 3 back over. And that's going to be my answer. Okay? Questions on that? So completing the square, it can get a little confusing, okay? But if we understand why we do it, why it works, it makes it a little easier. You don't need to FOIL this out every time. You just need to know to square that term after you divided it by 2. Okay? Go ahead and try the next one, and then we're going to go over it. We'll do one more problem, and we'll be done for the day. All right, so first things first, get everything set equal to 0. So x squared, whoa, what's happening? There we go. X squared minus 6x plus 4 is 0. Now I need to move the 4 over to the other side. So this becomes x squared minus 6x equals negative 4. Everybody with me so far?
Yep.
We all got that far. Okay. Now, I just need to
Divide 2 from -6.
divide negative 6 by 2. And what is that?
Or -3.
Negative 3. So we all got x minus 3 squared equals negative 4. And I've got to add 9. X minus 3 squared equals 5. And then to rewrite that, x minus 3 squared. Perfect. Questions on that? Anybody confused? Okay, don't overthink that process. All right, steps 2, converting to standard form. Okay, this is a little bit more lengthy, but pretty easy. All this means, looking at example 3. So I've got y equals 4 times x minus 2 squared minus 1. Okay? So all this is 0 equals 4 times x minus 2 times x minus 2 minus 1. Do you all see how I did that? If I change that y to a 0, just because that's what you got to do. Now we just got to solve this. Okay, so when we do this, I just got to FOIL this out. So now I have this. You could have FOILed these two first as well, because we know we can do multiplication in any order. 4x times x is 4x times negative 2, negative 8x, negative 8 times x, negative 8 times negative 2, minus 1. Combine like terms, y equals 4x squared
Minus 16x plus 16 minus 4.
plus just 15.
Oh, 15.
Yeah. That one's pretty easy, right? Just foiling, just knowing, really the biggest part on that one is just knowing that x minus 2 squared is the same thing as x minus 2 times x minus 2. Okay. Do we want to do example 4? No? Okay. We'll call it a day on this.